Hello, this is Dr. Mears, and today we are going to be learning about trigonometric identities part 2. I did make a part 1 if you would like to go back and watch that part 1. I'm also going to be showing you the trigonometric identities from part 1 right now, and that is just in case you haven't had them in front of you or you want them, you can pause and write them down, or you could capture the screen so that you have them. We are going to be using them today. And I did add the sine squared theta plus cosine squared theta equals 1, and the tangent 2 theta equals sine 2 theta divided by cosine 2 theta. Okay, so let's do some examples. Number 1, solve each equation for 0 is less than or equal to theta, which is less than 2 pi, giving your answers in terms of pi. Now, for these, I probably am just going to be using the unit circle. I'm not going to be using my calculator, but because I see this right here, it's always a good habit just to take your calculator and make sure that you're in the correct radian or degree mode. So since this is radians, I want to check my calculator is in radians just in case I need it. And then I'm just going to press second mode to quit out. So I am ready to go. Okay, so we need to use one of the trigonometric identities, and we're going to have to use the sine 2 theta trigonometric identity. So I'm just going to write that down right here, sine 2 theta, and that came from the sheet that I just showed you. Okay, and so when I see this sine 2 theta right here, I know that I can get the 2, I want the 2 away from that theta. So I'm going to change it so I have 2 sine theta cosine theta. So let's change that side. So 2 equals sine theta, and I just changed this side and I kept sine theta. So all I did right here is I changed double angle. So I changed it from a double angle, the 2, to a single angle. That's why I wanted to do that. I wanted to change it into a single angle. It'll help us to solve it much easier. Now I need to set this equal to 0. So I need to subtract sine from both sides. And this helps us set it equal to 0. So here I set to 0. Once I have it set to 0, I'm hoping that you see between these two terms, they both have a sign in them. So I'm going to be able to factor out the sign because I can't do anything with this. I can't solve this. I can only set two terms or two expressions equal to 0 when it's linked by multiplication. And we have a subtraction here. So what I'm going to do is I'm going to factor out a sign. So I'm going to take a sign out. So when we factor out a sign, I'm factoring it out from this first term. So if I take a sign out, what I have left is 2 cosine theta. If I take a sign out from here, now remember, this is 1 times. I have a minus 1 left. So I factored out sine. Okay. Now, since I have multiplication here, I'm able to separate these and solve. So I can put sine theta equal to 0 and 2 cosine theta minus 1 equal to 0. So I separated, set to 0, and now I'm ready to solve. So the first one right here, sine theta equals 0. So let's look. On my unit circle, remember, sine is the y value. Now, at 0 degrees, or even 0 radians, this is the point 1, 0. This is my y value. My y value is 0 at 0 radians. So theta equals 0. And since we have to go all the way around the circle, where else is it equal to 0? Well, I'm going to find this point right here, negative 1, 0. My y value is also 0. And this is at the 180 degree mark, which is pi. So 0 and pi. I don't need a degree mark on this because we are in radians. Okay. Where else? We're going to go one more time, right? So we can go back. So because this is less than or equal to 2 pi, I can keep going and I can land back on 360 or 2 pi. So there's my 3 answers there. Excellent. Okay, now let's solve this one. 2 cosine theta minus 1. So I'm going to add 1 to both sides. So I'm at 2 cosine theta equals 1. Okay. Yes, I divide by 2. So I'm at cosine theta equals 1/2 up here. Now, if I use my unit circle, okay, I need it positive, so I'm going to need it in the first quadrant and the fourth quadrant because remember, that's x. And so I'm looking for the point, the angle measurement of the point where cosine is 1/2. That's the x value. So what angle measurement is our x value? 1/2. That's what this is asking. And you're going to find that it's 1/2 at 60 degrees, which is pi over 3. So theta equals pi over 3. Now I need to keep going, right? So I need to go over here and I need to look for this larger angle where x is going to be 1/2. And I want to know this larger angle, and if you look on your unit circle, you're right, it's also going to be at 5 pi over 3. So I have a lot of answers here. And we're done. Now, if you wanted to use inverses, you could, but because it said in terms of pi, I knew that I was going to be using my unit circle. When you use your unit circle, you're going to be able to find your pi radian degrees. You can also memorize this. So if you're like, how did you do it? I memorize them. I memorize that this is x is at 1, when x is 1/2, that's 60 degrees, which is pi over 3. So that is a memorization technique. If you need a unit circle, you may take it out. All right, and number 2, the expression 32 sine x cosine x can be expressed in the form a sine bx. We need to find the values of a and b. So this is going to go back to that same formula that we used. Sine 2 theta equals sine 2 sine theta cosine theta. All right, first, I'm going to write this down. 32 sine x cosine x. I don't know why I'm writing c's all over the place. 32 sine x cosine x. We need to make it look like this. We have sine x and cosine x, right, everybody? Okay. There's a 2 in front. So it's going to be, we need to multiply some number by 2. And then we have sine x cosine x. So all I did was I wrote this down right here, but I wrote an x instead. So what number times 2 gets you back to 32? That's what you have to figure out. Or you can simply do 32 divided by 2. So that's 16. So this number in front is 16. Okay? Perfect. All right. Now what we have to do is they want it in a double, they want the double angle. They want you just to write this as just sine. They don't want sine and cosine. They just want sine. So we're going to have to change this part here. Okay? Do you see that? This is simply this. So what 2 sine x cosine x will now get shrunk down to, or it's a double angle, so it gets a little bit, sine 2x. All I did was instead of writing theta, I wrote 2x. And what comes down? The 16 comes down. Okay, so they want to know what A and B are. Well, A is the number that is in front, so A is going to be 16. B is the number next to x, so sine B is going to be 2. So A is 16 and B is 2. And that's it. It's using the formula, substituting it in. We had to find that missing number, and then we had to change it to our double angle. All right, the last one. Hence or otherwise, I love how IB loves to use those. This is actually Oxford. Hence or otherwise, solve the equation 32 sine x cosine x equals 8. For theta is less than or equal to for 0 is less than or equal to theta, which is less than or equal to pi. So they just want us to go from 0 all the way to pi here. Okay, that's it. They only want you to look at those two quadrants. So that's what this means. So make sure you're looking at this. This sets where your answers are going to lie. All right, so let's solve. So we have 32 sine x cosine x equals 8. Okay, and now what are we going to be doing? We're going to be changing this. So I don't want sine x cosine x. We can't solve with this. So what I'm going to use is what I found up here. So I'm just going to change it to 16 sine 2x equals 8. I just changed it out because I can't solve with sine x cosine x. I could solve with this. All right, what are we going to do now? Let's divide both sides by 16. Now we're just going into solving. Sine 2x equals 8 divided by 16 is 1/2. Excellent. So now I'm going to, we could do inverse if you want. Inverse sine of 1/2. And where is, so when we, in our unit circle, where is the y value now 1/2? And this is pretty cool. So let's just go back. The x was going to be 1/2 at 60 degrees. Okay, that's just pi over 3. So where do you think the y is going to be 1/2? Yup, this is 30 degrees. So at 30 degrees, it's going to be 1/2. 30 degrees in pi radians is pi over 6. So 2x equals, we have pi over 6, comma. Okay, so that's here. Where else is the y value 1/2? If you look on your unit circle, we are going to have it at 5 pi over 6 as well. Okay, now what do we do? That's it. That's all we're going to be hanging out at because we can't go past 180. So what are we going to do with these? We need to divide this by 2, this by 2, and this by 2. And when we do that, x equals pi over 12. You can simply multiply those and 5 pi over 12. And there we go. Those are our answers. This has been Dr. Mears and using trigonometric identities to solve part 2. Thank you.